So on number one, that's saying classify a quadrilateral ABCD, giving reasons for your answer. ABCD. So maybe myself, I didn't draw it accurately so, but check the one that is on the what? The one that is on the one that I've just sent now in the group. So when you look at that, that's in classify quadrilateral ABCD. So ABCD is simply a rectangle. When you are looking at it from the diagram that I've sent on the group, you are gonna be able to see it accurately. So they're saying we must classify it. So I'm gonna say ABCD. ABCD is a rectangle. Is a rectangle, right? So we must classify to say this is what? It's a rectangle. It's a rectangle. This is a rectangle. It's a rectangle, and then the reason why we say it's a rectangle is because of it has equal diagonals. So yeah, we're gonna say ABCD is a rectangle because it has what? Equal diagonal AC and BD bisect each other at E. So the reason, remember, in Euclidean geometry, each and every statement should be accompanied by the reason. I'm just gonna write the reason here. It's because of why are we saying ABCD is a rectangle, guys? It's because of it has what? Equal diagonals. It has equal diagonals. Are you all able to see? Equal diagonals. It's because of it has equal diagonals. AC, 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 and BD. And BD bisect each other at E, comma. You'll write bisect each other at E. Bisect each other at E. So that's how basically it is. And then from here, as we are now done with that, we have answered number one. Now we are going to number two. So in answering number two, what are you gonna do? So now we are on number two. So all of this, what I'm teaching you, you'll actually understand it from the concept of me teaching you those basics of what? Those basics of what? Of Euclidean geometry. So on number two, that's saying determine giving reasons X, Y, and Z. So they want us to calculate the size of X, Y, and Z, right? So since now you understand Lukuti, ABCD, it's a what? It's a rectangle. They want you to calculate X, Y, and Z. Ne, it means to say, you're gonna say angle ADC. I'm gonna say angle ADC is equals to 90 degrees. Angle ADC, it's equals to 90 degrees. Why am I saying angle ADC is equals to 90 degrees? Angle ADC, when I'm talking about ADC, you start at A, you go to D, you go to C, right? So this is ADC, this angle right here. This angle is equals to 90 degrees. Why is it equals to 90 degrees? It's because of those are angles in a rectangle. So you know that angles in a rectangle, let me show you. A rectangle is like this. And then since we have classified to say that is a rectangle, you know that in a rectangle or a square, we are having a 90 degrees. Just like that. So the reason why I'm saying angle ADC is equals to 90 degrees is because of that is an angle of a what? Angle in a rectangle. So remember, each and every statement should be accompanied by the reason. I'm going to say angle in a rectangle. Angle in a rectangle. A rectangle. And you're not limited only to you saying angle ADC. Someone here can just decide to write and say, therefore, can write it properly to say, myself, I prefer writing it like this. Angle D is equals to 90 degrees. It's still one and the same thing. You know why? Because these two, it's one and the same thing. Either you write it like that or like that. It's one and the same thing, right? So angle D is equals to 90 degrees. Not only that, also the whole of angle A right here is equals to 90 degrees. Also the whole of angle B is 90 degrees. Also the whole of angle C is 90 degrees, because that is a what? That is a rectangle. And then you know that sum of angles in a quadrilateral is 360. When you say 90 times 4, you must get 360 degrees. Do you all see, guys? Do you all see? Do you all see? Do you all understand?
Yes, sir.
Yes. Any question?
No.
Any question? Okay, let's proceed, guys. Let's proceed. So after that, remember question number 2, we're doing number 2. We're still on the question that's saying determine giving reasons X, Y, and Z. So this is D right here. Ne? That is D. So I'm gonna say the whole of angle D. That angle D, it comprises of two angles, which is equals to angle what? Which is equals to angle X. We'll write it here. Plus another angle is 2x plus 6. That is 2x plus 6. That is the one that you are actually given. Do you see? And then here, in a place of D, you substitute by 90 degrees because they told us, oh, we know that angle ADC, it's 90 degrees because that is an angle in a rectangle. Or you can just say D is equals to 90 degrees. It means to say where there is D, I'm writing 90 degrees. So I'm just going to write 90 degrees. I'm just going to write 90 degrees. We welcome you, Minentle, and everyone. So I'm going to write 90 degrees, guys. It's equals to, then you add, remember here there's a coefficient of 1. You can write it, you can also leave it. 1x plus 2x, those are like terms. They give us 3x. So you're going to write 3x, guys, and then you do what? You say plus 6. And then from here, I'm going to write 90. Then I'm going to take positive 6, I transpose it that side. When I transpose it, it changes the sign to become negative 6. Then that's going to be equals to what? 3x. And then let's subtract. What is 90 minus 6? What is 90 minus 6? Let's all subtract. What is 90 minus 6?
84.
84.
Wait,
You write 84. It's equals to 3x.
yeah, it's 84.
Okay. And then who can tell me when I solve for x here, what should I do?
Divide both sides by 3.
Why do I divide both sides by 3? Who can explain to me why do I divide both sides by
And
3?
then 3 is gonna cancel 3.
Yes. You divide both sides by 3 because math says what you do on the left hand side, you also do it on the right hand side. Tangish? And then 3 cancels 3.
Yes.
Therefore,
X equals to
we welcome you, Tilidzi. Angle x is equals to, what is 84 divided by 3?
28. 28.
Yes, 28 degrees. I'm going to say 28. So 28 degrees is your correct answer here. Any question? And then that's how you solve for x. And then, as you now continue, let's now continue solving. We are done solving for x. And then, because the question wants us to find x, y, and z. So we can actually find what? We can actually find what? Angle y. So, who can tell me what are the properties of a rectangle?
Properties of a
rectangle. Okay, let me teach you. So when we speak about a rectangle, it has both pairs of opposite sides being equal in length. And actually we know that ABCD it's a what? It's a rectangle. So it means to say one of the properties of a rectangle, we know that both pairs of opposite sides are what? They're equal in length. So if they're equal in length, I must show to say the length of AD is always going to be
can I say them?
equal to the length of BC. Can you say what?
Can I tell you the what's this? What parts of the rectangle? Properties of the rectangle.
Yes, you can tell me. So one of it, it's both pairs of,
Corner
yeah? Yes, I'm listening.
angles equal to 90 degrees.
Yes, I've said that each and every
Opposite sides.
opposite sides what?
The other one is opposite sides are parallel and equal in length.
Yes. The one that opposite sides are parallel, it means to say, guys, you are correct, Minent. It means to say you must go to the what? To the diagram to show that, you know what, guys, these opposite sides are parallel and equal in length. That's why I've shown with the blue lines there to say the length of AD is equals to the length of BC, because those opposite sides are equal in length. But not only that, Minentle mentioned something to say opposite sides are parallel. So I need that one. Yeah, parallel lines. You must write it. So it will help us to find what? It will help us to find the size of the angle what? Size of angle Y. Right? I'm going to say AD. The length of AD, guys, is parallel to the length of what? To the length of BC. Why? It's because of opposite sides are parallel. Opposite sides. That is one of the properties of a what? Both pairs of opposite sides are parallel of a rectangle. You will just write both pairs of opposite sides are parallel. Both pairs of sides are parallel. Both pairs of opposite sides are parallel. Please write it properly. Both pairs of sides are parallel. And then you now knowing to say, hey, both pairs of opposite sides are parallel. Then there is something that is very important that is going to appear. Look at the green. Okay. Look at the green zone that I'm highlighting. Do you all see, guys? Do you all see? Do you all
Yes.
see? Or let me try maybe a different color that is clear. Which one is clear? Okay, let me try this one. Yeah, look at this brown color that I'm showing you. It means to say this angle right here, which we call it angle ADB. Let's write it. That is angle ADB. Angle ADB, it's equals to what? To this angle right here. Angle DBC. It's equals to angle DBC. Those are alternating angles. Taking it from what you have learned. Angish? So you'll just say alternate angles are equal. Because you now know to say, oh, those are going to be what? Those are going to be parallel lines. But if you didn't know this, where is the part of alternating angles coming from? It's coming from an understanding to say, we now know one of the properties of a rectangle to say both pairs of both sides that are parallel. If you don't know that property, you're not going to be able to solve the size of angle Y. And then after that, now we go to the diagram, we now substitute. Angle ADB, which is this one right here, it's given a size of angle X. So you're going to say angle X, because ADB is represented by angle X, it's equals to what? It's equals to the size of angle DBC. So DBC there is given by size of angle Y. And then the next step, you ask yourself a question. You have recently calculated the size of angle X. So we actually got that our X value is what? Is 28, right? So in a place of X, you're going to write 28. So that will be 28 degrees. It's equals to Y. And then therefore, the size of angle Y, we know that it's going to be what? 28 degrees. So that's how we get it correct. We are done calculating. Number 2, we are only left at calculating the size of z, because on number 2, that's saying determine giving reasons x, y, and z. So we got x, which is 28. We got y, which is 28. And then for you to be able to get this correctly, if you want, you can go back to the diagram and substitute the values of those. The values of x on the diagram, please substitute it, as well as the value of y, so that you can make your diagram to be neat. Any question? Lani, any question?
No, sir.
Sure. Minentle, any question?
No, sir.
Sure. It's Lani, Minentle, and Tiro, any question?
No, sir.
Sure. Naldo, any question?
No, sir.
Okay, sure. Sipo, any question?
No, sir.
Sure, Sipo. Michael, any question? Michael, any question? Okay, let's continue. So yeah, I believe most of you, I'm not sure if there's someone whom I left behind.
Delete or something.
Yeah,
Yeah.
Tilidzi, any question? Yeah, I saw that I left someone. Tilidzi, any question?
No, sir.
Okay, sure. Yeah, I started with girls and then I went to boys. I forgot to say there is also Tilidzi. Thank you, Tilidzi. Apologies for that. Yeah, so that's how, guys, we solve it, ne? But we are not yet done. We need to calculate the size of what? The size of angle Z. So now, when you're looking at angle Z, where is Z? Where is Z? Oh, there you go. I'm not seeing it here. Yeah. This is the size of angle Z. So one thing that you need to understand, let's look at the length of EB and EC. EC and EB. Can you see that these two lengths are equal? Look at this. I'm going to say the length of EB, it's equals to the length of EC. Do you all see? They've shown it on the diagram. Look at this. They told us that the length of EB, which is this one, is equals to the length of EC, which is that one. Do you all see? That is given. The length of EB is equals to EC, right? In triangle what? In triangle EBC. So if you want to write it properly, you can just say the length of EB, it's equals to the length of EC. And then what's going to be the reason? The reason is actually given. We were actually given. So you'll write given. And then after that, guys, as you now proceed, it means to say, therefore, what's going to happen? Therefore, what's going to happen? Angle EBC, taking it from that statement, angle EBC, let me write it properly. Angle EBC, it's always going to be equals to angle ECB. Angle ECB. So that is opposite sides equals opposite angles. Remember that each and every statement should be accompanied by the reason. So you'll just write opposite sides. Opposite sides equals opposite angles. So in matter of fact, yeah.
How did you do this one?
How did I do what?
Oh no, man, there isn't. Why is it opposite sides equal to opposite angles?
Yes, I was about to explain it just now. So let's look at triangle EBC. So I'm gonna try to write triangle EBC aside so that you can understand. Was it Minent? I'm hearing the voice.
Yes.
I think it's Minent. Yeah. EBC. So let's extract triangle EBC, guys, from the diagram. So EBC is this one, which is red. Look at this red. You see, the red one that I'm drawing, that is triangle EBC. Do you see? And then, with regards to that, here we are having that size, which is, let me write it with a different color. We are having Y here. On that triangle EBC, we are having Y. And then here we are having actually C3. And then they told us that this side is equals to that side. So that's why here, I'm saying EB is equals to EC here. Yo, there is someone who, guys, please let us not move the diagram. Michael, please don't move my diagram. You see now, my screen is actually adjusted. Please, let's cooperate, guys. You are disturbing me. Don't move the screen. Please don't press. Let us not press anything, guys. Because if you're pressing, I'm gonna get disturbed. So here, as I was explaining, triangle EBC is the one that we are having on the yellow diagram. So since they gave us on this statement here, as I was explaining, to say EB is equals to EC, the moment they tell you that EB is equals to EC, it's a must that this size of angle Y is going to be equals to this size of what? Of angle C3. So that is, do you see? And then our angle EBC here is given by, there's someone who's asking me a question. So this is size of Y. It's equals to ECB. You can just write ECB there. And then this means that you can also go to the diagram here at ECB. You know that that is going to be the size of Y right there. Because we want to get what? We want to get the size of angle Z. So one thing that you need to understand from just me looking at the diagram, I'm going to say E7 is equals to angle Z. E7 is equals to angle Z. This statement is very important. Angle E7, it's equals to the size of angle Z. Who can tell me what's going to be the reason? Why am I saying E7 is equals to the size of angle Z? It's because of
vertically opposite.
Yes. Vertically opposite. Correct. I'm not sure who was that, but correct. Vertically opposite angles are equal.
It's minenhle sir.
Oh, sure, minute. Vertically opposite. Vertically opposite. Who don't see it? Vertically opposite angles are equal. Are you all guys? Are you all fine? That is the one that I taught you from Fun Talks. I think it's a week ago. To those who were here, I told you Fun Talks, Anish. So when you look at E7, it's equals to Z. This statement, you take it from Fun Talks. When two straight lines intersect, it means to say the vertically opposite angles are equal. What are those vertically opposite angles are equal? That is angle Z here is equals to E7. Vertically opposite angles are equal. And then, after now you know that, you're going to concentrate on the yellow diagram that I'm going to draw. You see this yellow? Okay, let me try to highlight it. You see this yellow part that I'm highlighting? Look at this. We're going to use that concept of an exterior angle of a triangle is equals to sum of two opposite. So E7, it's equals to angle EBC, which is represented by Y, together with angle C3. The exterior angle of a triangle is equals to sum of two opposite interior angle. So I'm going to say E7 is equals to EBC. E7, I'm going to say angle E7. E7 is equals to angle EBC. EBC plus, let's look at it. E7 is equals to EBC plus angle C3. Plus angle C3. So when you look at E7, let's check. Remember, we want to calculate a Z here. So E7 is the same as Z from this statement that I just recently wrote, this one. E7 is equals to Z. It means to say where there is E7, I'm going to write Z here. I'm going to write Z. It's equals to. Then let's look at angle EBC. On the diagram, or from what you are having, angle EBC is given by Y. Is this one right here. We're giving it as Y, which is that one. So I'm just going to write size of angle Y. That is going to be the size of angle Y that represents EBC plus, let's look at C3. I've explained it again. C3 is this one even. If you can't see it properly, it's this one. I said this one is also going to be equal to that one. So it means to say also C3 is represented by Y. If you don't see it properly, go back to the diagram. You will see it. I wrote it somewhere. Yeah. Look at C3 on the diagram. You can see that it's having Y. I wrote it there. So C3 is also angle Y. So you go there. Where there is C3, you must also write Y. You must write angle Y. And then look at this. The size of angle Z, you put a copy to show that you are talking about an angle. It's equals to, when you add 2Y, when you add Y plus Y is 2Y, right? You can just say 2Y right here. And then now you substitute. You can just say angle Z, it's equals to 2 into, what did we get the size of angle Y to be? What did we get Y being? Y it was 28, Anger. You're going to write 28 degrees here. 28 degrees. And then you multiply. Therefore, the size of angle Z, it's equals to, what is 2 times 28? That is 56. That is 56, guys. It means to say this is 56 degrees. But we are not restricted. Let me show you another concept from here. Someone will just write it like this. Someone will say, me, I prefer writing it like this. You're not going to be wrong. Angle Z is equals to, so since you know that this is Y plus Y, and it was like this, Y plus Y. So someone can also write it like this and say, the size of angle Z, it's equals to, you know that Y you got what? Y you got 28. So you can write 28 degrees. You are not going to be wrong. It's still correct. You can write 28 degrees plus another 28 degrees. Therefore, the size of angle Z, what are you going to get? 28 plus 28 is still 56 degrees. Still going to be 56. Do you see? So there are many ways to kill a cat. So from here, you can also use that concept that I wrote with a green marker there. But it's still one in the same thing because you're still going to get the same answer. So any question? So we are done with Z. And then
Sir.
yes? Any question?
After this session, can you please send the videos, the session videos?
No problem. So on a battery, they're saying if AB is equals to 8, since AB is equals to 8 sharp, Ashile Laibon on the diagram, and AD is equals to 15, they want you to calculate the length of BD. Now, this one, for you to calculate it, it needs you to come with an understanding to know. One of you said, here, each and every angle is going to be 90 degrees. So it means to say you take out that triangle aside, you draw it aside. So that is going to be A, where we are having a 90 degrees here too. And then this is going to be B2, B, and then that is going to be D. So here we are having 8. Can you see? Here we are having 15. And then they want you to calculate this size. It means to say it's a right angle triangle. You can use the theorem of Pythagoras. That says the hypotenuse side squared, which is BD, is equal to the sum of the squares on the other two sides, of which are given 8 and 15. So it means to say, with regards to that one, you'll use theorem of Pythagoras to accurately solve it. So since you understand what it there, it's in triangle what? In triangle ABD, then you use theorem of Pythagoras. The hypotenuse side squared, which is going to be BD, the one that they want, BD squared, is equals to the sum of the squares on the other two sides, which is going to be AB, we are given, the length of AB, that will be AB squared, plus the length of what? The length of AD squared. Plus AD squared. Now substitute. And then you're going to find the length of BD. Let's now substitute using theorem of Pythagoras. So that will be BD squared. It's equals to. So the length of AB were given 8. So that will be 8 squared plus the length of AD we are given 15. Then you solve the unknown. 15 squared. Then therefore, you know that you're going to square both sides.